In JavaScript, nothing moves without a name. Nothing exists without a place to live. But here's the twist. Before you even type a single line, the engine has already decided the fate of your code. Your variables, your functions, your scope, all predetermined. Today, we tear the curtain open. We step inside the hidden machinery that runs JavaScript, and we see the truth. By the end of this course, you'll fully understand 4 essential concepts: variables, scope, functions, and hoisting. Variables are not just simple containers for data. They are names, labels we give so our code can find and work with information stored in the computer's memory. Think of them as a bridge, connecting the ideas in your program to the actual values that live in memory. But this connection isn't permanent. It can change, adapt, and be updated as your program runs. In JavaScript, a variable holds a reference to a value, not the value itself, except for primitive types. And that's where things get interesting. To understand why, we first need to split JavaScript's values into 2 categories: primitive types and reference types. Primitive types are the most basic kinds of values. They are stored directly inside the variable, not by reference. There are 7 primitive types in JavaScript. Number, like 42, 3.14. String, like hello. Boolean, true or false. Null, represents an intentional empty value. Undefined, means no value has been assigned. Symbol, a unique identifier, like symbol, ID. Big int, for numbers too large for normal JavaScript numbers, written like 123n. Reference types work differently. The actual data is stored somewhere in memory called the heap. The variable doesn't hold the value itself. It holds a reference, like a pointer, to where that value lives. Assigning a reference type to another variable, both variables point to the same memory location. Change it through one, and the other changes too. Examples include objects, like name, alley, arrays, 1, 2, 3, functions, function, and other built-in types like date, map, set, and more. Example of objects in JavaScript. We create an object called book with a property, title, set to JavaScript basics. Then we create a new variable, library, and assign it the value of book. Here's the catch. Library is not a copy. Both book and library point to the same object in memory. Think of it as 2 remote controls controlling the same TV. When we log book.title and library.title, both show JavaScript basics. Now, if we use library to change the title to advanced JavaScript, book.title also updates to advanced JavaScript. Key takeaway: objects are shared by reference. Changing one changes all, unlike primitives, which are copied by value. Example of primitive variables. We assign x equals 10, then y equals x. Change y to 20, x remains 10. Primitives are independent. Each variable owns its value. Simple, predictable, no hidden connections. How values behave in memory. Primitives store actual values directly in a small box on the stack. Reference types store a pointer to data in the heap, the real treasure map. Copying primitives creates a new independent value. Copying references, only the address is copied. Both variables point to the same object. Mutability. Primitives are immutable. Any change creates a new value. References are mutable. Contents can change in place. Why this matters. Misunderstanding this can break your code and silently create bugs that are hard to find. Primitives are small, fast to copy. References can point to massive structures in memory. JavaScript gives us 3 ways to create variables: var, let, and const. But before diving in, understand this. Scope. Scope is the region in your code where a variable lives, where it can be seen and accessed. Think of it as a house. Your variable is the furniture, and the house decides who can walk in and see it. Try to use a variable outside its scope, and the engine won't recognize it. It will throw an error. JavaScript has 3 types of scope: global, function, and block, introduced with let and const. Global scope example. A variable declared outside all functions lives everywhere. like a fruit basket in the kitchen, accessible by everyone. Function scope example. Variables declared inside a function exist only there. Outside, gone, invisible, like a secret room. Block scope example. Variables inside curly braces exist only there. var ignores blocks. Let and const respect them. Want safety? Use let or const. Var function scoped, visible inside the function. Let block scoped, visible inside nearest curly braces. Const, like let, but cannot be reassigned. Now, brace yourself. We uncover JavaScript's hidden force. Hoisting. Before execution, JavaScript scans for all variable and function declarations, then lifts them to the top of their scope. What gets hoisted? Variable declarations, var, let, const, only the declaration, not the value. Function declarations, full function, body included. Why care about hoisting? Misunderstand it, and your code surprises you. Debugging then? Painful. Var allows early use, prints undefined until assignment. Let and const? Temporal dead zone. Accessing early zaps you with reference error. Functions, reusable blocks of code, take inputs, parameters, process, return a value. Function declarations are fully hoisted. Call them before writing, they still work. Function expressions? Only their name is hoisted, not the body. Calling early? Boom, error. Variables, scope, hoisting, functions, the four pillars of JavaScript. These aren't just rules, they're the laws of your code universe. Understand them, and you stop being a passenger. You become the architect. With variables, you give ideas a name. With scope, you decide who sees them. With hoisting, you predict your code's future. With functions, you craft reusable machines. Master these, and you don't just write JavaScript, you control it. This is just the start. See you in the next one.